When does the iteration for phi-index stop? When do we know that the phi-index is the final one? Learn it here in hydrology. The next problem for phi-index contains a record for time in minutes and rainfall depth in millimeters. The basin has an area of 50 square kilometers with a recorded total direct runoff of 10 mm. So to answer the question on when to end the iteration, what we have is the record of time and rainfall depth. These parameters are ample in solving for the phi, as we have a simple equation of P minus phi times T as equal to R. P is the accumulated rainfall or precipitation. T sub E, or just plainly T, is the accumulated duration. For this parameter, take note of the two cases. The first case is when the time intervals are regular, meaning rainfall depth is taken at the same time jumps. For example, every hour or every 30 minutes. The T sub E is computed as M times delta T. M is the number of pulses. The second case is when the time intervals are irregular, like jumps could be anywhere from 1 hour to 1.5, then 2 hours to 5 hours, and so on. In this case, take T sub E as the summation of delta T. Delta T is the incremental time. The last parameter from the equation is accumulated or total direct runoff. This parameter can either be provided in the table or is given. So when do we stop iterating? This is where the hytograph comes into action. The hytograph is a plot for time and rainfall intensity. The ordinate, rainfall intensity, shows the amount of precipitation, and the phi-index shows the amount of water that infiltrated the soil. The remaining heights from the rainfall intensity is then the runoff, which we can use in water projects. The phi-index works on a concept that the amount of rainfall is equal to the amount of runoff. In case the phi-index is as high as shown, there are two time intervals lower than the index. This contradicts the concept. So the iteration continues until such time that after the phi-index, all time intervals still show a runoff. Now that P and R are either provided or can be computed from the table, we then proceed in creating the hytograph, and that starts with the rainfall intensity. We then mark each entry as a pulse, then check the time. The record provides time in minutes, but rainfall intensity needs hours. So extend another column for the conversion, then divide each time entry by 60. 30 minutes is half an hour. 75 minutes is 1.25. 120 minutes is 2 hours, with 180 minutes as 3 hours. 250 minutes is 4.167 hours. 360 is 6 hours, and 450 is 7.5 hours. With time already in hours, let's focus on the rainfall intensity. This is taken as the incremental depth over the incremental time. So check time. The values are increasing from 0.5 to 7.5. This means that the record has cumulative time, and we need to convert it into incremental time. So again, place another column in the table. The first entry is 0.5, less 0 giving 0.5. 1.25 minus 0.5 is 0.75. 2 less 1.25 is another 0.75. 3 less 2 is 1. 4.17 minus 3 is 1.17. The next is 6 less 4.17, which is 1.83. With the last entry of 7.5 minus 6 as 1.5 hours. Half of the rainfall intensity is already identified. Next is to check the column of rainfall depth. It starts from 13 all the way up to 84 in an increasing manner from each entry. This means that what we have is the cumulative depth, which again should be converted into incremental depth. The first entry is 13 minus 0, which gives 13. Then 26 less 13 is 13 also, with 39 minus 26 as 13 again. 51 minus 39 is 12, followed by 65 minus 51 as 14. Next, there is 75 minus 65 as 10, and 84 minus 75 is 9. We have now the numerator for the rainfall intensity. Compute for the rainfall intensity by dividing the incremental depth by the incremental time. The first entry is 13 divided by 0.5, giving 26. 13 upon 0.75 is 17.33, and there are two entries of them. The next is 12 over 1, which is 12. Then, 14 divided by 1.17 is 12. The next entry is 10 upon 1.83, giving 5.46. Then 9 minus 1.5 is 6. Now we have the rainfall intensity. This is what we compare with the phi-index later. We don't actually need to plot a graph, but you may do so if you think you needed a clearer picture. Now let's start iterating for the phi-index. For the first trial, we consider all the 7 pulses. Our guide is the function p minus phi times t as equal to r. P is the accumulated rainfall. You can either take the summation of the incremental depth, which turns out as 84, or you can look at the last entry from the accumulated depth, which should be the same, 84. For t, take the summation of the incremental time, which shows 7.5. You can also use the last entry from the accumulated time, given as 450 minutes, which is also 7.5 hours. Run of r is given in the premise as 10 millimeters. The function then is 84 minus 7.5 phi as equal to 10. By arranging terms, we get phi as 84 minus 10 all upon 7.5, which gives 9.87. The phi-index is compared with the rainfall intensity, and we can observe that there are two intensities lower than the phi-index. This is a sign that we continue iterating. So let's work on the second trial. This time, we disregard the two pulses having intensities lower than the computed phi. This leaves us with only 5 pulses left. Then we identify the new values of the parameters of the equation. P is the summation of the incremental depth, which is now 65 millimeters. Time is also taken as the summation of incremental time, which is 4.17 hours. The runoff remains the same as 10 millimeters from the premise. Plug all these into the equation, giving 65 minus 4.17 phi as equal to 10. Phi is then 65 minus 10 all over 4.17, resulting to 13.199 millimeters per hour. Now compare the index with the remaining intensities. It is again observed that there are two entries with intensities of 12. They are lower than the index, which means the iteration should continue. For the third iteration, take out the next two entries which have the intensities lower than the last value of the index. Then determine the new values of P and T sub E. The summation of precipitation from the 3 remaining entries is 39 mm, and the summation of time is 2 hours. Again, R is provided by the problem to be 10 millimeters. Place these values into the function to have 39 minus 2 phi is equal to 10. Phi is then 39 minus 10 all over 2, and this gives 14.5 millimeters per hour. Check the intensity of 26, which is more than the index. Then 2 of 17.33, which are also higher than the index. This shows that we have arrived at the final phi index, and it is 14.5 millimeters per hour.